None of you guys reminded me to hit record. So the people that are home aren't going to be able to do this.
Why are you always subtracting 2?
That's the rule.
But why 2?
Why not 8?
Well, because you need at least 3 sides to make a figure, right? So like a triangle adds up to 180, right? So, but it has 3 sides. So 3 minus 2 is 1 times 180. Okay. I realize that's not a proof, but is that good enough for you? Yeah. Okay, so I'm just going to quickly go back for those people that are watching by video that aren't here, because I forgot to hit record at the start. So there's the types of polygons, not regular because the angles are different, not regular because the angles and sides are different. Regular sides and angles are the same. There's all the names. If you're watching at home, you should hit pause and fill those in. Parts of a polygon, again, hit pause, fill those in. Okay, back to real life. So the angles of a triangle add up to 180. Angles in a quadrilateral add up to 360. We can find the sum of angles in any polygon by using 180 times n minus 2, where n is what? N is the number of sides in a polygon. Right? And we did a little bit of that already. I think I handed out that sheet, right? The one with the angles on it? Yeah, I think so. So if you didn't get that, you can get that. We can use this to find the measure of one angle. Oh, that's it. Okay, so let's talk about central angles now. I hate geometry. I'm not a big fan of geometry. This is the last one. Sum of the central angles in a polygon always equals 360. The sum of the central angles. So when you take all of the center angles and add them together, it's always going to be 360. And the measure of one central angle can be found by 360 divided by n. Here we do not divide by or subtract 2. Kelsey, right? And again, n is the number of sides in a polygon. Okay? Now, diagonals run from one corner in a polygon to another. So in a square, there's only 2 diagonals, right? This one and this one. Why does that not count? Why does that not count? Well, because those are sides, right? So 4-sided figure, how many diagonals? Josh, 4-sided figure, how many diagonals? 2. How many in this one? There's 1, 2, 3, 4, 5. There's 6 sides here. How many diagonals? Now, should we count them? Where should I start? 1, 2, 3, 4, 5, 6. Now, that one I've already got. 7, 8. That one I've got. That one I've got. 9. Are there any others? So in a 6-sided figure, there are 9. So here's the rule, the formula, the equation. The number of diagonals in a polygon can be found by n times n minus 3 divided by 2. You have to write that in? Yeah, it looks like you do.
What's our test about the next question?
All of this stuff, sine law, cosine law, and all this stuff on polygons. Yeah.
What polygons are all the shapes?
Yeah. We'll do review, but make sure you have all the notes. Remember, on Schoology is all the notes as well. The number of diagonals in a polygon can be found by n times n minus 3 divided by 2. So, for example, in a square, Bodhi, that would be 4 times 4 minus 3 divided by 2. 4 minus 3 is 1, because I wanted you to pay attention instead of looking at that calculator. 4 minus 3 is 1 times 4 is 4 divided by 2. 4 divided by 2 is 2. Right? Yeah, it's not hard. In a 6-sided figure, that's going to be 6 times 6 minus 3 over 2, which would be 6 times 3 divided by 2, which would be 18 divided by 2, which was 9. Right? So you can use that formula, or you can count if you want. And I think, if I'm not mistaken, this is Kozlowski, you might be able to help us. I remember seeing something about where on the exam, if you do it by counting, you have to show your work somehow, or...
Yes, I don't think you can just
I don't think you can just count and give an answer. You have to somehow visually show that you're trading.
Like draw them all in.
Yeah.
Okay.
Yeah.
That number is
I don't know, 18? 6 times 3? 18, right? Divide by 2.
Oh, good.
Are we all good? There's a couple of examples here. Oh, not hardly anything else. Everyone good? Yeah? Bodie, you good? Staying with us? Okay, so here's an example. What shape is made by connecting the tips of each petal of this flower? So you guys have the picture there. I'm going to draw in red so you can see here. So if we connect the tips, well,
there's 10 sides.
yeah, but we're only connecting the tips.
Oh.
So that is 5-sided. Bodie, what are you doing with the calculator? So why is that so interesting? Like, is that what he's doing?
No.
Typing that number in so it says boobies upside down. Really? That's what he's doing? We were doing that in the 70s, man.
You're a little late.
Yeah.
That's late, bro. God damn.
Tough to do with a slide rule, though, right, Mrs. Preslowski? Yeah. What angle would be made at each tip? What angle do we have here? It's 5-sided figure. So they're really asking,
120.
It's a pentagon.
it's 180 times n minus 2, right? Pentagon.
Central angle.
Doesn't say central. Each tip, right? I'm going to move this up here. So it would be n times n minus 2 times 180. Did I get the rule right?
Yep.
These are not ones I have memorized.
Yep.
Okay, good. So 5-sided figure, 5 minus 2 times 180. So that's going to be 5 times 3 times 180. Pentagon.
Okay, is that,
Did I do
are
something
you
wrong?
figuring out a number of diagonals?
No, it says what angle would be made.
Oh, okay, yeah.
Right? So they wanted, that doesn't make sense. What did I do wrong?
It should be 180 n minus 2.
I always get this formula wrong.
And then 180.
Oh, it's not n times n minus 2, right? It's just n minus 2.
N minus 2.
Gotcha. My mistake. My mistake. N minus 2 times 180. Alright, see, I don't like this stuff.
Yeah.
It's not my favorite. 5 minus 2 times 180, so 3 times 180. Yeah, that makes more sense. So, oh, that's just the total. That's just the total, isn't it?
Yeah.
So how am I going to find the angle of each one there? The total is 540 degrees. Yeah, we're going to have to divide by 5, right? We're going to have to divide by 5, right? 108 degrees. I'm guessing you have to put the little degree symbol, or it's a half mark off probably,
Yes.
would be my guess.
You
Yeah.
bet.
Okay, that makes sense. Think we got it, Robert? There's one more here, right? A nonagon is a 9-sided shape. How many diagonals would it have? Well, let's do it both ways. Let's do the counting. Okay, you've got a nice big one there, right? So let's pick one to start at. I'm going to pick at the top. 1, 2, 3, 4, 5, 6. So now that means that every one should have 6 coming from it, right? I don't think that's necessary there, right? But some of them are going to be doubled up. So now we got 1, 2, 3, 4, 5, 6. Now we go to the next one here.
Yeah.
1, 2, 3, 4, 5. Did I get them all?
Scale down a little bit.
Or is there a double up? 1, 2, 3, 4, 5, 6.
Jesus Christ.
Okay,
Oh,
right,
language.
right, come on.
Public filter.
Public filter, exactly. Was there a double up there, or did I just count wrong? 1, 2, 3. Oh, this one we already was already there.
Yeah.
Right? That one was already there, so I only made 5 new ones, right? See, there's the problem with the counting.
I know, you can read.
Is like, and I just demonstrated that. Is that I didn't draw that one. I started counting here, right? So I only really drew 1, 2, 3, 4, 5 new ones. Right? And then when I go down to here, how many do I have? Maybe this is the way to do it. There's 2 there. I know there's 6 for each one, so that means I'm going to add?
3 more.
No, 4 more.
Sorry,
Right?
4 more.
See, there we go. It's easy to make mistakes, right? 1, 2, 3, 4. From this one, I've got 3, so I need 3 more. 1, 2, 3. From this one, I've already got 4, so I need 2 more. Not a tumor. Did I put the 2 there? I did. And then from this one here, 1, 2, 3, 4, 5, I need 1 more to there. That is not a good way to do this.
No, it's playing.
Let's add these up. 6 and 6 is 12, 9 is 21, 24, 26, 27. We got 27. Yeah. Let's use the rule. The rule was n times n minus 3 divided by 2. So let's try it this way. Let's try that. Hey, Mrs. Timchuk, can you just give us the quick, very 10-second version of what they have to show on the exam if they're doing this and they have to count? They want to count. Is there some they have to demonstrate, like they have to draw them all?
They'll do one or the other.
Yeah.
They'll do the formula, or if you want to count, then you'll have to draw.
You have to draw them all. That's what I thought.
Yeah, I'm definitely not drawing.
Yeah. The drawing is probably not advised. Yeah. Okay. Thanks. That's what I thought.
Make paper look pretty good.
You could. I remember as a kid we're doing string art like that. That was always
Yeah,
fun.
oh, for sure.
And if you draw them in, there's a thing that's on the marking thing, that we actually have to count them and make sure they're there. So if you miss one,
I'm definitely drawing them now.
Just to be a jerk.
This will make you do your job. Can we do both ways? You get paid for this.
you could, but if you miss one in your drawing, then which one? Because you only mark one, so if they just mark the drawing one.
Taking a chance.
Points.
What is this? 9-sided? So it's going to be 9 times. Thank you, Mrs. Timchuk. 9 minus 3 all over 2. Is that right? 9 minus 3 is 6. 9 times 6 is 54 divided by 2. 25, 26, 27. Is that what I counted? Chicken soup.